Today we will learn Chapter 1 Decision Procedure. We already know what a decision procedure is. Decision procedure is a method which decides whether the statement form is tautology or not a tautology. It also decides whether the argument is valid or invalid. For it to be effective, we know that it should satisfy certain conditions. That is, it must be reliable, finite, and mechanical. Reliable means by using this method, we must get correct answer provided we use the rules of logic correctly. Secondly, it must be finite, meaning it must contain limited number of steps, and we must also know the last step. Thirdly, it must be mechanical in the sense that we must use those rules of logic mechanically and no intelligence must be required to construct it. This decision procedure is based on basic truth tables of truth functional compound propositions, that is, the truth values of truth functional compound propositions. And decision procedures are of two types: truth table, which we have studied last year, and shorter truth table, which we will be studying this year. But why don't we rely on truth table, and why shorter truth table has to be introduced? You already know that truth table method contains two parts. One is matrix and the other is truth function. The matrix of the truth table contains rows and columns and combination of propositional variables, and the number of rows and columns in the matrix of a truth table depend upon the number of propositional variables in the given expression. If the number of propositional variables increase, then what will happen? The number of columns and rows will also increase. So this procedure will be lengthy and time consuming. Lot of carefulness also will be required to construct it. So we cannot rely on truth table, and much shorter method is needed. That is shorter truth table. Shorter truth table is based on the principle of reductio ad absurdum. It is an indirect method, whereas truth table method is direct method. And shorter truth table method also is a decision procedure which decides whether the statement form is tautology or not a tautology. It also decides whether the argument is valid or invalid. It is reliable, finite, and mechanical, and is also based on the basic truth tables of truth functional compound propositions. So, unlike truth table, shorter truth table is an indirect method, whereas truth table is direct. Now we will understand how to construct shorter truth table. Now we will see the steps to construct shorter truth table as a test for tautology. We already know what tautology means. Tautology is that statement form which is always true below the main connective in all the rows. So we are going to assume that the given statement is not a tautology by writing F below the main connective, which is our assumption, and we will mark it with a star. If the main connective is an implication or disjunction, then there is only one possibility under which it is false. So apply it, and with the help of the basic truth tables, assign the truth values to its various components, that is, to the connectives and the propositional variables. Also number each step. After completing the table, truth table, check whether there is any inconsistency to the given rules of logic, whether they are violated or not. Inconsistency may be when the same propositional variable has both truth values, that is when it is both true and false, or when any of the rules of the basic truth tables are violated. If there is inconsistency, then mark it with a cross. So our assumption is wrong and the statement form is tautology. If there is no inconsistency, then our assumption is correct and the statement form is not a tautology. Note, while assigning the truth values to its components, apply the rule if the possibility is 1. But when the possibility is more than 1, then replace the truth values of both the propositional variables. 8. If you cannot replace the truth values of both the propositional variables, then replace the truth value of one propositional variable which you know and get the truth value of the other propositional variable from the basic truth table. 9th, if the main connective is equivalence or conjunction, then we have more than one possibility. So, solve one by one. If we get no inconsistency in the very first step, then stop there and the given statement form will be not a tautology. But if we get inconsistency, then we will solve the second possibility and so on. So, till we get no inconsistency. In the case of equivalence, if we get inconsistency in both the possibilities, then only it is tautology. Let us see with few examples how to construct shorter truth table as a test for tautology. The given statement is P and Q, then P. Let us see how to construct. What is the main connective here? The main connective is horseshoe. So it's an implicative statement. And we already know what tautology means. Tautology means always true below the main connective in all the rows. So we are going to assume here that the given statement is not a tautology since it is an indirect method by writing F below the main connective. So we are going to write F below horseshoe, which is the main connective, and mark it with a star, which indicates that it is an assumption. Now we'll have to assign the truth values to its component statements and their connectives. So let us see when is an implicative statement false. We can see that an implicative statement is false only under one condition, when its left is true and its right is false. You know that the components in an implicative statement are given names. The left component is called the antecedent and the right component is called the consequent. So the antecedent of this implicative statement is true and the consequent is false. What is the antecedent? Antecedent is a conjunctive statement where conjunction is the main. So below this conjunction dot, we are going to write true, and on the right side, that is the consequent, is P, below which we'll write F. And we will number it as 1, 1. Now we will have to assign truth values to these conjuncts. So we'll have to see when is a conjunction true. Conjunction is true only under one possibility. That is, when both the conjuncts are true, the left conjunct and the right conjunct both are true, then only it is true. So we'll assign the value true to P and true to Q. And we'll number it as 2, 2. Now, since we have finished with assigning the values to the propositional variables as well as their connectives, we'll have to check whether there is any inconsistency to the given rules of logic. We already know that inconsistency may arise when any rules of truth functional compound propositions are violated, the basic truth tables, or when the same proposition has both the truth values. Let us check. See here, P is having the truth value as false. At the same time, P is having the truth value as true. So a proposition cannot have both the truth values. So it's violating the rule of logic. There is inconsistency. Let us mark it with a cross below it. Now, since there is inconsistency, our assumption is wrong. That is, it is not F, but there is T. So the given statement form is tautology. Let us take a second example. This statement, what is the main connective in this statement? Again, the main connective is horseshoe. So this statement is also an implicative statement. So we are going to write F below the main connective and mark it with a star. This indicates that this is our assumption. Now we will assign the truth values to its component statements and their connectives. Now when is an implicative statement false? It is false only under one condition. That is when the left, that is the antecedent, is true and its consequent is false. So what is this antecedent of this implicative statement? Antecedent is P equivalent to curl Q, where equivalence is the main. So below this main, we are going to write true. And what is the consequent? The consequent is this bracket, where wedge is the main. So below wedge, we are going to write, let us write true, false, and number it as 1, 1. Now you can see that on the right side, wedge or disjunction is false. So when is it false? We'll have to assign values for its disjuncts. So when is it false? Only under one condition, that is when both the disjuncts are false. So what is on the left of this disjunction? Curl P. So below curl, we will write F. And below Q, we will write F. We will number it as 2, 2. Now, since we know the curl P's value as false, what will be the P's value? Just opposite of that. When curl P is false, then P will be true. So we will assign the value to P as true and number it as 3. Now we will go on the antecedent side where equivalence is true. When is an equivalence true? An equivalence is true when both its components have equal truth values. That is, when both are true or when both are false. So there is more than one possibility of it being true. So in this case, we will replace the values of both the propositional variables. Since we know the values, truth values of both the propositional variables, let us assign the value of P. P is true. So we will assign here P as true. And we will number it as 4. Then we will assign the value of Q as false. And we will number it as 5. Since Q is false, its negation will be true. So we'll write the value as true and number it as 6. Now we have finished with assigning the truth values to its components and component statements and their connectives. Now we'll have to check whether there is any inconsistency in this statement. Let us check. Q's value is same, P's value is same. The rules used are when both are true, then the equivalence is true. That is also correct. Everything is correct. There is no inconsistency. So our assumption is correct. That is, it is false below the main connective. So the statement form is not a tautology. I will take the third example. What type of statement is this? Here the main connective is wedge. That is, it is a disjunctive proposition. Okay. So we are going to write F below the main connective, that is below wedge, and mark it with a star. Now, when is a disjunction false? Let us see. A disjunction is false only below one condition, that is, when both the disjuncts are false. When the left disjunct is false and the right disjunct is false. So, what is on the left of this? This bracket where conjunction dot is the main. So below dot or conjunction, we are going to write F and number it as 1. And on the right also, we will write below curl P, which is the main, as F, and we will number it as 1, 1. Now, since the negation of P is false, then what will be P? It will be true. So you can see here, if the negation of P is false, then P is true. So we are going to assign P's value as true and we will write 2. Now let us solve this. When is conjunction false? Conjunction is false when at least one of the conjunct is false. So that is, there are 3 possibilities. So we cannot apply the rule and we have to replace the values of both the propositional variables. Let us replace the values. P's value is true. So we are going to write P's value as true, 3. We'll number it as 3. Here also we will assign the value as T. It is 4. And negation of that is false, that is 5. Now we have assigned the truth values to all the components and their connectives. I will have to check whether it has violated any rules of logic, whether there is any inconsistency. P's values are correct. The rules used are correct. If the left is true and the right is false, then conjunction is false. It's correct. This rule is also correct. So there is no inconsistency. So our assumption is correct. It is F and not T. So the given statement form is not a tautology. Now we will come to the fourth example. Let us see what is the main connective here. The main connective here is wedge. That is, it is a disjunctive proposition. So we are going to write F below the main connective, that is wedge, and mark it with a star. When is a disjunction false? A disjunction is false only under one possibility, that is when both the disjuncts are false. So what is on the left? There is a bracket where horseshoe is the main connective. So below that we are going to write F, and on the right hand side there is a bracket where wedge is the main. So below wedge again we are going to write F. Let us assign the values F, F, and we are going to write 1, 1. Now we know that disjunction is false only under one condition, when the left disjunct is false and the right disjunct is false. So what is on the left of this disjunction? Curl Q. So curl is the main, and on the right hand side there is curl P. So curl is the main on both the sides. So we are going to write below curl, both the curls F, F, and number it as 2, 2. When the negation of P is false, then what will be P? Negation of P is false and P will be true. So we'll write true. We will write true and we will number it as 3. Now we will have to assign the value to Q. If curl Q or negation Q is false, then Q will be true. And we will number it as 4. Now we come towards the left side of the disjunction, this left part. When is horseshoe false, or when is implication false? When its antecedent is true and its consequent is false. You can see here the left is true and the right is false. What is on the left side of this horseshoe? Curl P. So curl is the main. On the right hand side curl Q. So curl is the main. So on the left curl we are going to write true, and on the right curl we are going to write F. Just right and number it as 5, 5. Now since not P is true, then P will be false. So let us assign the value, will be 6. We'll number it as 6. Since negation of Q is false, then Q will be true. We'll number it as 7. Now since we have written all the truth values, now we'll have to check whether there is any inconsistency. Let us check the P's value. P's value here in step 3 is true, whereas in step 6 it is false. It's wrong. Q's value is the same, but P's value is wrong. Okay. So there is inconsistency, we will mark it with a cross at step number 3 and 6. Since there is inconsistency, our assumption is wrong and the given statement form is tautology. So you have to mention the steps in which you find the inconsistency. Now we go to the next example. Now we will do the fifth one. What is the main connective here? Equivalence. Triple bar. So below the main connective we'll write false and mark it with a star, which indicates that it is an assumption. When is an equivalence statement false? An equivalence is false below two conditions, that is when the left is true and the right is false, or the left is false and the right is true. We are going to assign the values. Now on the left, what is the main? Negation of the bracket. So negation is the main. So below that we'll write true. This is our first possibility. We'll write true, and below she will write false. And we'll number it as 1. Now, when is an implicative statement false? An implication is false only below one condition. What is that? When the left is true and the right is false. That is when the antecedent is true and the consequent is false. What is the antecedent of this implicative statement? Q. And what is the consequent? Negative P. So we'll write below Q and negation. So left will write true and right below negation will write false. This is 2, 2. Now since the negation of P is false, what can be P? It will be true. So you can see here we will write true and number it as 3. Now since the negation of the bracket is true, what will be the bracket? That is the main in the bracket is which. Below which we will get false. And this will be the fourth step. Now when is which false or when is disjunction false? Disjunction is false only below one condition, when both the disjuncts are false. That is left side also it is false and the right side is also false. So you will apply this rule and write P and Q's values. False, left disjunct and right disjunct false. So 5, 5. Now since we have completed the whole table, we'll have to check whether there is inconsistency in this statement. Let us see the P's value. It is true, but P's value is false here. So there is inconsistency. So we'll mark it with a cross. Now see Q's value, Q is true, whereas Q is false here. So here again inconsistency 2 and 5. Since we have got inconsistency in the first possibility, we will have to solve the second possibility. Now we'll write F, mark it with a star. This is our, now we are going to solve the second possibility. Now what is the second possibility? The left is false and the right is true. So left you will write as false and right side you will write true. Now you will write number it 1, 1. Now if the negation of the bracket is false, what will be the bracket? True. This is true. Now since there are three possibilities here under which it is true and there are three possibilities here under which it is true. So what we will do, either of the cases we will solve. Means we cannot replace here the values of the propositional variables also, and there are three possibilities. But how do we get these possibilities? Three. Here implication we get three possibilities because we know that an implicative statement is true in either of the cases when the antecedent is false, okay, then it is true, or the consequent is true, then an implicative statement is true. So let us write on the right hand side as true. That is sufficient. One value is sufficient for it to be true. So we are going to write the truth value on the consequent side. Truth value of consequent, true. We'll number it as 3. Now, since negation of P is true, then what will be P? It will be false. We'll number it as 4. Now, since we know the value of P, we can replace the value of P here. We can replace it and we will get false 5. Since wedge is true and the left disjunct is false, wedge is true. See here, wedge is true and the left disjunct is false, then what can you say about the right disjunct? It must be true. So you'll write true and this will be our 6th step. Now you can replace the value of P in this bracket and you will get T7. Now there is no inconsistency. You check P's value we are replacing, so it will be the same, and even the rule is correct. See here, check the rule, it is correct. There is no inconsistency in the second possibility, so the whole expression will be not a tautology. Now we will do the 6th example. Let us see. The main connective again is equivalence. That is triple bar. So it's an equivalent statement. So we'll have to write F below the triple bar and mark it with a star, which indicates that it is our assumption. Now, when is an equivalence false? There are two possibilities. Let us solve the first possibility. When the left is true and the right is false. So what is on the left hand side? The bracket where wedge is the main. So here we'll write true, and on the right the bracket where horseshoe is the main, there we'll write false. Let us assign the values 1, 1. Okay. Now on the right hand side, when is implication false? When the antecedent is true and the consequent is false. Only under one condition. So let us assign the value to P as true and Q as false. This is 2, 2. Okay. Now we will solve this. This is true when in at least one of its disjunct is true. So we have 3 possibilities here. We cannot apply the rule and we will replace the values of both the propositional variables. What is P's value? True. Let us assign P's value and we'll number it as 3. Now, if P is true, then not P will be false. We'll assign the value as false and write it as 4. Now, what is Q's value? Q is false. So, we'll assign Q's value here. Get false, and this is number 5. Now since we have assigned the truth values to all, now we'll have to check whether there is any inconsistency. You can see that curl P is false and Q is false, so wedge has to be false. But this is true, there is inconsistency in step number 1. So our assumption is wrong. So we'll have to solve the second possibility. Let us solve the second possibility. Write false, the star, What is the second possibility? When the left is false and the right is true. Right here as false and here as true. 1, 1. Now we'll have to solve this side because this is false only under one condition, when both the disjuncts are false. So left is curl P. So below curl we'll have false, and on the right Q we'll have false. This is 2, 2. Since negation of P is false, then P will be true. You can see here, here true, and number it as 3. Now we'll be solving on the right hand side. This is true when in either of the cases when the antecedent is false or the consequent is true. But there are three possibilities. So what we do, we can replace the values. We'll replace the values of both the propositional variables. P's value is true, so we'll replace here as true. Number it as 4. I will replace the value of Q here as false. We will number it as 5. Now we'll check the rule used is correct. If the left is true and the right is false, the antecedent is true and the consequent is false, then implication is false. But here it is given is true. So there is inconsistency. It has violated the rule of implication. Since we have inconsistency in both the possibilities, so the given statement form is tautology, since our assumption is wrong in both the cases. Whole expression will be tautology. Now the seventh one, let us see. What is the main connective here? Again, it is triple bar. So it's an equivalent statement. Equivalence is the main. We write F below it and mark it with a star. When is equivalence false? When it has unequal truth values. That is, we have more than one possibility. So we will apply the first possibility. What is the first possibility? When the left is true and the right is false, left is negation of the bracket. So below the negation, we'll write true. And on the right, the bracket where the main is dot conjunction where we'll write false. We'll number it as 1, 1. Now, since the negation of the bracket is true, then the bracket will be false. That is, wedge will be false. You can see here. Write it as false and number it as 2. When is disjunction false? Disjunction is false when both its disjuncts are false. So left disjunct is false, that is P is false and Q is false. Let us assign the values. See here, we'll assign the values as false, false 3. We'll number it as 3, 3. Now we'll solve this side. Conjunction is false when at least one of the conjunct is false. So we have three possibilities. So we cannot apply the rule and we'll replace the values of the positional variables, that is P and Q. P's value is false, we'll write it as false, number it as 4, and here we'll write Q's value as false. You can see here it is false, so here also we will put false and assign it as 5. Now check the rule, it's correct. There is no inconsistency in the first possibility, so no need of solving the other possibilities. The whole expression will be not a tautology since our assumption is wrong. Correct. Assumption is correct, it is F, so it is not a. So now we go to the next, that is 8th one. Here the main connective is dot, conjunctive statement, conjunction is the main. So we write F below conjunction dot, and mark it with a star, which indicates that it is our assumption. Now when is a conjunctive statement false? Conjunction is false when at least one of the conjunct is false. So there are three possibilities. So we write the first possibility. Left is true and the right conjunct is false. Now solve it 1, 1. When is a disjunction false? A disjunction is false only under one condition, when both the disjuncts are false. So left disjunct is Q and the right disjunct is P. So below P and Q we will write false, false. We'll mark it as true, true. Okay. Now, here when is implication true? Implicative statement is true in either of the cases when the antecedent is false or the consequent is true. So there are three possibilities. We cannot apply the rule, so we'll replace the values of both the propositional variables. P is true, false, and Q is false. Let us write P's value as false, we'll number it as 3. Q's value as false, we'll number it as 4. I will check the rule. If both the sides it is false, then what is implication? When both sides it is false, then implication is true. Okay. So let us see here true. So this is also true. It's correct. There is no inconsistency in the very first step. So the given, there is no need to solve the other possibilities, and our assumption is correct and the statement form is not a tautology. Let us do the ninth one. Here, what is the main connective? Dot. So it is conjunction. It is conjunctive proposition. Now you have to put or write F below the main connective, that is dot, and mark it with a star which indicates that it is an assumption. Now when is conjunction false? Conjunction is false below three possibilities. So we will solve each possibility one by one. The first one is the left conjunct is true and the right is false. So we are going to do the first possibility. That is the left is true and the right is false. On the left there is negative Q. So negation is important. There you will write true, and on the right the bracket is the main. So we will write false below horseshoe, which is the main connective, and we will number it as 1, 1. Now what will you do? When is implication false? Implication is false only below one condition, when the antecedent is true and the consequent is false. What is the antecedent here? Q. And what is the consequent? Negative P. So below Q you will write true, and below negative sign you will write false. This is the number 2. Now we come to Q's value. What will be Q's value? If negative Q is true, then Q will be false. But before we go to the negative Q, we have to first write the value of P. So we will write the value of P. You can see if negative P is false, then P will be true. So that will be third step. Now we go to the Q's value. Q, if negative Q is true, then Q will be false. This is 4. Now since we have assigned the values to all the propositional variables and their connectives, we are going to check whether there is any inconsistency. Can you see any inconsistency here? P's value, Q's value, yes, there is inconsistency. Q is true, whereas not here Q is false. So we mark it with a cross. Since we have got inconsistency in the first possibility, we will have to solve the second possibility. What is the second possibility? First we will write the statement, we will negate it by writing F below the main connective and we'll mark it with a star. What is the second possibility? The left is false and the right is true. So left side will put false here and right will put true. Right, true. So now we'll number it as 1, 1. When is implicative statement true? There are three possibilities. So let us write the value of Q. If not Q is false, then Q will be true. This is 2. Now, since there are three possibilities, we will have to replace the values of both the propositional variables. Since we do not know the value of both, we will replace the value of one which we know. So, Q is true. So, we will replace your Q's value as true. So, this will be third. Now, when left is true and implication is true, when it's if in a true implicative statement, if the antecedent is true, what can you say about the consequent? It must be true. So the negative P is true, that is 4. Now since the negative P is true, what will be P? It will be false. So this is 5. Now we'll check whether there is any inconsistency. See, you can see it's correct. Both sides true. So true. Q is true. So Q is here also true, and P is once only. So there is no inconsistency in the second possibility. So the whole expression is not a tautology. Here, now we come to the next 10th one. Here also dot is the main connective. It is a conjunction. It is a conjunctive statement. So we write false below the main connective. Mark it with a star, which indicates that it is an assumption. Now when is dot false? Below three possibilities. So we are going to solve the first possibility. When the left is true, here there is a bracket below which in which horseshoe is the main, so below that we'll write true, and on the right wedge is the main, so in that bracket we'll write false below the wedge. Now we'll number it as 1 and 1. When is wedge false? When is disjunction false? Disjunction is false when both the disjuncts are false. So we'll write on the left it is negative Q, so below the negation we'll write F, and on the right P, so we'll write F below P also. Now we'll number it as 2. Now if negative Q is false, then what will be Q? You can see if the negation is false, then the proposition will be true. So this is 3. Now here there are three possibilities, so we'll have to replace the values of both the propositional variables. So P's value is what? F. So we'll write F and we'll number it as 4. Q's value is true. So we will write true below Q and we'll number it as 5. Since we have assigned the values to all the propositional variables, so now we'll have to check the whether there is inconsistency. You can see that the left component means the antecedent of this implicative statement is true and the consequent is false. Yet this is true. Actually it should be false. You can see here if the left is true and the right is false, then the implication should be false. But here it is true. So there is inconsistency here. We mark it with a cross. Now since we have got inconsistency in the first possibility, we will have to solve the second possibility. We write false below the main connective and mark it with a star. Now second possibility, what you are going to do, see here, dot left is false and the right is true. So solve it. Left horseshoe we are going to put false and wedge we are going to put on the right true. 1, 1. Now here there are three possibilities, so solve the left side. When is implication false? Implication is false when the left is true and the right is false. Antecedent is true. What is the antecedent? Q. So below that it is true and below P it is false. So it's 2, 2. Now you just replace here because there are three possibilities. P's value is false, so you write false, you number it as 3. Q's value is true, so you number it as 4. And what is the negation of Q? If Q is true, negation will be false, so it is 5. Now since we have assigned the values, now we'll have to check whether there is inconsistency. Let us check. There is no here inconsistency. Everything is correct. But here there is inconsistency. Since negative Q is joining P with wedge. So to check the value of wedge, we have to see the values of negative Q and negative and P. So both are false, then what is wedge? If both are false, then wedge is false. But here it is true. So there is inconsistency. We mark it with a cross. Since we have got inconsistency in the second possibility also, we will have to try out the third possibility. What is the third possibility? Both the conjuncts are false, then a conjunctive statement is false. Write that false, mark it with a star. This is the third possibility. Write false on both the sides. Now, when is wedge false? When both the sides it is false. So mark it with 1. We write false, false. 2, 2. Since negative Q is false, then Q will be true. So this will be 3. Now we'll solve on the left side. When is implication false? When the left is true and the right is false. The antecedent is Q. Right, true. And P is false. Consequent. So we mark it with number 4. Now we'll have to check whether there is any inconsistency. See here, there is no inconsistency. The rules used are correct. The variables are also having the same values. So there is no inconsistency in the third possibility. So the whole expression is not a tautology. Now we'll do the 11th one. What is the main connective here? Curl. The whole statement is in the box bracket and there is a negation sign outside it. Means it is a negative proposition. So below the negation outside the bracket, we are going to write F and mark it with a star. When is a negation? When the negation of the bracket is false, then what will be the bracket? True. What is the main in the bracket? Horseshoe. So what you're going to write there? True. Okay, 1. Now when is implication true? There are 3 possibilities below which it is true. And here we cannot replace the values. So we are going to use that when either the antecedent is false or the consequent is true, then it is true. So let us either put here false or here true. Anything will do. Any one truth value you have to write. We have written false. So we write there 2. When is wedge false? When both the disjuncts are false. So left is negative P. So below negation and on the right Q. So below Q you write false. Right? 3, 3. Now negative P is false and P will be true. So this will be 4. Now on the right hand side, we will replace the values of both the propositional variables. P's value is true. Okay. Right. There are 3 possibilities. We'll write true. We'll write false. For Q, this is P is 5 and Q is 6. Now negative Q will be true. This is 7. Now you know that a conjunctive, when the left is true and the right is true, what left is true and the right is true, it is joining, conjunction is joining a negative Q. So this is true and this is true, then what will be, or conjunction will be true. So this will be 8. Now we will have to check everything. Is there any inconsistency? See, P's values correct, Q's values correct, rule applied are correct. So there is no inconsistency. So the given statement form is not a tautology. Now we go to the next 12th one. Here again the whole statement is negated because there is a box bracket and a negation sign outside the bracket. So we are going to write false below the curl and mark it with a star, which indicates that it is an assumption. When the negation of the bracket is false, then what can you say about the bracket? It has to be true. What is the main in the bracket? Dot. Below that we are going to write true and number it as 1. When is conjunction true? Below one possibility it is true. So we are going to write true on both the sides. That is, brackets are there on both sides. On the left, horseshoe is the main, so below that, and on the right, wedge is the main, so below that we'll write true, true. Now we'll number it as 2, 2. Now there are 3 possibilities on both the sides. Either you solve this or this. Anything will do. We'll solve horseshoe. When is implication true? When the either of the cases when the consequent is true or the antecedent is false. Because there are three possibilities and we cannot replace the values, we are using this rule. Now if number it as 3 and if the negative p is true, then p will be false. Then this is 4. Now p is false, you replace the values of all the p's. Okay? Because there are 3 possibilities here also. P's value will be, this is 5, 6. Okay? Now you will write another piece value there false. There is inconsistency here itself. If you want to replace the value, you can, or you keep it as it is. Since you have got inconsistency already, when both the sides it is false, then wedge has to be false. So inconsistency is marked with a cross, and the given our assumption is wrong. It's not F, but it is T. So the given statement form is tautology. Now we come to the 13th one. Here also the main connective is curl because there is a box bracket and a negation sign outside it. So below the negation sign outside the bracket, we'll write F and mark it with a star, which indicates that it is an assumption. Now since the negation of the bracket is false, then the bracket will be true and wedge is the main in the bracket. So disjunction below that we are going to write true, which is when is wedge true? There are 3 possibilities. So how do we get this possibilities 3? When at least one of the disjunct is true, it is true. So any one side you'll write true, let us write it on the right side. When this is 2. When is conjunction true? Conjunction is true only under one possibility when both the conjuncts are true. So below P we write true and below Q we write true and number it as 3 and 4. 3 and 3, sorry, this you are applying the rule, so 3 and 3 you will get. And now since Q is true, we'll write Q's value and write 4, and since Q is true, then negation of that will be false, so that is statement fifth step. And now you check whether there is any inconsistency. There is no inconsistency in this step, so the given statement form is not a tautology. Now we come to the 14th one. Again, the main connective is negation of the bracket. So negation is the main connective. You write false below the main connective, put a star. Now, since the negation of the bracket is false, then what can you say about the bracket? It has to be true. Number it as 1. Now when is when is equivalence or triple bar true? It is true below 2 possibilities. That is when they have equal truth values on both sides, that is both are true or both are false. So in this case, both the sides values you are assigning, so it's better to solve both. Okay, it is always both the possibilities you have to solve, because we are assigning values on both the sides of the main means connective, which is inside the bracket. So what we'll do, we'll write true, first possibility, true, true. Number it as 2, 2. Now you go on solving when is not true, when both are true. You can see this. We will write true here, and negative p will write true. This will be 3, 3. So p's value will be false. 4. Now you can see there is inconsistency in 2 and 4. So you mark it with a star. Now we'll have to solve the second possibility. What is the second possibility of triple bar? When both are false, it is true. So write that. Both are false, then it is true. This is true, true. Now, since dot is false or conjunction is false, when there are 3 possibilities, okay? So in that case, we replace the values. Since we know the value of p, we can replace the value of p. Okay, this will be 3. If the p is false, the negation of p will be true. This will be 4. Since in conjunctive proposition, if the conjunction is false and the right conjunct is true, then what can you say about the left conjunct? It must be false. So we are going to assign the value false below q and write it as 5. Now we will check if there is any inconsistency. There is no inconsistency in this step. Okay, in any of the steps, so the given whole expression is not a tautology. In the second possibility, I have got no inconsistency. Now we come to the 15th one. What is the main connective here? Horseshoe. So it's an implicative statement, an implication. You write false and mark it with a star, which indicates that it is our assumption. Now, since implication is false, when is it false? When the left is true and the right is false. So what is on the left? The box bracket where dot is the main. So below the main connector, that is dot, we'll write true, and below on the right side wedge is the main in the bracket. So we'll write false, we'll number it as 1, 1. When is a disjunctive statement false? A disjunctive statement is false only under one condition, that is when both the disjuncts are false. So write here false and here false. P is one disjunct and R is another one. So false, false. Number it as 2, 2. Now, when is a conjunctive proposition true? When both the conjuncts are true. What is on the left of this? The bracket in which wedges the main. So below that you will write true. On the right, curl Q is negative p, so negation is the main. So below that true. So true below wedge and true below negation. This is statement 3, 3. The negation, if the negation of q is true, then the q will be false. So it's 4 step. Now, since there are 3 possibilities below which we have disjunction, there are 3 possibilities. So what we'll have to do, we'll have to replace the values of both the propositional variables. P's value is false and Q's value is also false. So replace your false, false. P's value is false, number it 5, Q's value is false, number it as 6. Since we have assigned the values to all the propositional variables and their connectives, now we'll have to check whether there is any inconsistency. Let us see if both the sides it is false, then disjunction is false. But here it given is true. So there is violation of rule, there is inconsistency, which we marked it with a cross. And since we have got inconsistency, our assumption is wrong. That is not F but T. So the given statement form is tautology. So in this session you have learned how to construct shorter truth table as a test for tautology. Thank you.